You are looking at a functional fitness app with custom navigation and a polished interface. It was built without writing a single line of code. This chart shows the development timeline and revenue potential of this specific app archetype. On the left, traditional coding requires months of expensive iteration. On the right, agent-driven prompting reduces that timeline to minutes, giving you a viable product ready for market testing almost immediately. To start, you need to set up your workspace. Head over to the Google Anti-Gravity site, download the desktop application, and sign in with your Google account. You don't need a computer science degree to do this. You are no longer a programmer trying to remember syntax. You are a product manager giving direct instructions to an AI agent. Step 1. Open Google Anti-Gravity and initialize a fresh project. During the initial setup, the software will ask you to select a development style. You must choose Agent-Driven Development. Standard AI coding tools act like autocomplete, guessing the next line of code. Agent-driven development operates differently. You describe what you want to build, and the AI reasons through the architecture, writing large chunks of the application on its own. We get the most accurate results from the agent by breaking the build into small, manageable components. We will start by asking the AI to build only the visual structure. Instruct the agent to create a 5-tab fitness app. Add the exact constraint, create only the front end with no functionality. We are generating mockups only. Once the environment compiles, click through the dashboard, the track section, the history log, the built-in timer, and exercise library. Verify that the navigation works and placeholder data is aligned on the screen. Securing this visual blueprint early means we know exactly how the app flows before we complicate it with logic. We have a stable skeleton. Now we can give it a brain. Now we transition from a static design to a working tool, starting with the track section. We instruct the agent to replace placeholder data in the track section with actual logic, allowing user inputs for exercises, sets, and weight. Log a test workout to see your reps recorded in the UI, but watch what happens when the session ends. The workout completes and the data immediately vanishes. Being able to input numbers is useless if the app forgets them a second later. Logic has to be tied to a persistent state, or a database, to actually retain the information. To fix the vanishing data, we need to wire the output from the tracker directly into the app's history section. In the prompt bar, tell the agent to create the workout history section. Specify that whatever workout the user logs from the tracker must be saved and displayed in this new section. Log one more test workout. When the session ends, the app auto-navigates to the History tab, and your data is permanently saved right there. To keep users inside our app during their actual workouts, we need to add a built-in timer. Prompt the agent to replace the timer placeholder data with functional timers. Explicitly request 2 features, a custom duration dial and a grid of quick select presets for standard rest periods. Run a quick test on the new interface to ensure the countdown operates smoothly and doesn't freeze the rest of the application. By individually prompting the UI, the input logic, the data persistence, and the utility tools, you have taken a fragile mockup and turned it into a cohesive, reliable product. Look at the final build. You started with a blank environment, and you now have a fully functional React Native application. You accomplish this level of technical output in minutes, entirely through natural language instructions. The final step is moving your project from a local build on your desktop to a live, published product on the App Store. Check the link in the description for a step-by-step guide on the publishing process and start testing your app in the real market.